Hi everyone, so today we're going to be taking a look at Ollama. Ollama is basically a local AI model management tool, and it allows you to download models, set up models locally on your PC, open source models to be exact, and it also gives you access to a command line interface and also an API endpoint where you can actually chat with these models locally, and it's really simple to set up. All you have to do is download it, and I think it's available for the three main OSs, Linux, Mac, and also Windows. Once you've done downloading it and you've installed it, it will give you access to the command line interface, which all you have to type in is Ollama. And if you want to list all the models you've actually downloaded, all you have to do is impute Ollama list, and you'll get the list of models you've downloaded. And as you can see over here, I have Llama 3.2 Vision, and I also have mini CPM V. Now, this is the reason why I'm actually creating this video, because I did promise that when Llama 3.2 Vision is available to be installed locally, I'm going to create a video specifically for that. And we're only going to be touching on Ollama. We won't be checking it out on LM Studio because it's not currently available on LM Studio. And I do not want to be creating a separate video for LM Studio because I do not know when it's going to be out. And by then, Llama 3.2 Vision might be an old news or something. So let's just forget about LM Studio for now and focus on Ollama. Now, if you want to download this model on Ollama, all you have to do is go over to ollama.com and you can click on models, and you're going to see the list of models. If you don't see Llama 3.2 Vision here, make sure you do search for it here and make sure you click on it, and you're going to see Ollama run Llama 3.2 Vision. That if you want to go for the 11 billion parameter model, as you can see here, we have two models listed here, 11 billion parameter and also 90 billion parameter, which means you can actually get the 90 billion parameter if you do have the VRAM for it, if you do have enough storage and enough CPU memory to run this, then go ahead and do that. But the total size of the 11 billion parameter model is 7.9 gigs, as you can see over here. And now you can copy the command, go over to your terminal and paste it. And now what Ollama run does is it checks if this model is already downloaded on your PC, and if it is already on your PC, it just loads it up for you. And if it's not, it starts downloading it automatically, and the moment it's done downloading, it then loads it up. But if you just want to download it for now, and maybe you don't want to load it up yet, and you don't want to chat with it yet, maybe you want to do that later, then you can change this run command to pull. And the moment you do that, all it does is it downloads the model and just exits. That's all it does. It doesn't load up the model for you. So you can come back later and do the Ollama run, Llama 3.2 Vision. That's if you just want to download it alone. But since we're going to play around with this, we're going to run it. So let's hit enter. And it's going to load it up. And since I have just 16 gigabytes of unified memory, it's going to take a while, and it's also going to be really slow since this is 7.9 gigs, and it actually has to load this up to my memory. Now let's say hi. And as you can see, the output was kind of slow and it took a while for each token to actually appear. So the next thing we're going to do is we're going to give it images, and we're going to check how well it actually understands those images. And we're going to ask it something about that particular image, and we'll see if it actually does see really well, or if it can understand images really well. So let's do that now. And the first thing I'm going to do is show you the image. So this is one of the images we're going to be passing to the multimodal large language model to see how well it actually understands memes. And the other image we're going to be passing in is this one, and this is the image we're going to go into more details with. I'm going to ask it different questions about this table. So this image is basically a motor KV recommendation table, and it has the prop diameter and also the battery voltage, and it shows you the different battery voltage. It depends on the one you want to go for, and also the different sizes of prop. Let's say you have a 5-inch drone and you want to run it with 6S. These are the recommended KV of motors that you will go for, and you will be fine. Same thing if you have a 5-inch drone and you want to go for 8S, you'll be fine with this. So let's go over to our terminal and pass this image in and ask it about this particular image. And maybe we will ask it to describe the image first, and then we'll ask it what are the recommended motor KV for 4-inch props. So let's ask it to describe the image. Like I said, this might take a while. Okay, and it's done, and it said the image appears to be a table comparing propeller diameters to recommended motor kV ratings. Not bad, it actually got it kind of right. And let's ask it a different question. Let's ask it, as you can see, it actually failed in that regard because I think it went for something else. And let's just ask it to use from the image. It keeps getting it wrong. It's supposed to be 2000 to 3000, but let's ask it about it keep answering the question wrong. So I'm going to try this again. Let's give it the image and let's ask it the question. So let's try. Okay, let me pass in the image. It keeps saying the same thing. Let's ask it for a 5 inch. Okay, you got it right this time. And say 2000 to 2200. As you can see over here, kV. It actually got it right this time. So the only question it failed is the first question, but for the second one regarding the 5 inch props and the 6S battery, it actually got it right. So let's move on to the meme. Let's see if it actually does understand meme. So let's go and let's pass in the image. This should be really simple. Let's see if it does understand it. Okay, it actually gave us an answer. The image displays a graphic that compares decoupling visual encoding to single visual encoders. Decoupling visual encoding and also single visual encoders, which is accurate. And it says the title, it's got the title correctly. Visuals, two dog images. Yep. One representing decoupling visual encoding left. That's nice. And it actually knows your position, which is cool. The other single visual encoders. The image effectively conveys a comparison between decoupling visual encoding and single visual encoders through a clear and concise graphic. Use of dog images adds a touch of creativity to the design, making it more engaging. Overall, the image provides helpful visual aid for understanding the difference between. Yeah, it's not really a visual aid per se, but we'll take it as long as it can actually understand text and also the images that is being presented in this whole image, and I'm going to just take it that way. But it's supposed to understand that this is a meme basically. Maybe the 90 billion parameter model will do a much better job at knowing that, yeah, this is a meme, not just some visual aid or something. So the next thing we're going to do is we're going to use the Ollama library in Python. It's going to be a very simple setup. So let me just show you how it's done. So if you look over here, you can see that we have the setup, and let's copy this. But make sure you have your Python virtual environment already set up and you have your project folder already set up, because I won't be showing you how to do that in this video. This video is basically a simple guide on using Ollama. So let's copy this and go over to our IDE. So as you know, I have my Llama 3.2 vision already downloaded, so I won't have any problem running this code. But something you can actually do is change this to, so it would allow you to input whatever you want, and you can also pass in whatever image you want here or images you want into this array. But I'm going to copy an image and paste it into our project directly so I can actually use it here. And we're going to ask it to describe the image like we did previously. And now let's run main.py. Make sure you have your virtual environment active. Let's run it now. As you can see, it's asking us for a message, and I'm going to ask it to describe this image. So this basically is the image we are sending over to the multimodal large language model to, and we are asking it to describe the image. So let's see what it will output. And we actually got an output, and as you can see, it says the pie chart displays the distribution of various animal species, with each section labeled and colored distinctly. The sections are arranged in a clockwise direction, starting from the top. Section breakdown, hogs, orange, it got the color right, 30%, and it also got the value right. Frogs, blue, it got the color, 15%. Logs, red, it actually got the color and also the value, 10%. Dogs, green, and 45%. That's good. Total distribution 100%. This pie chart provides a clear and concise visual representation of the proportion of each animal species, allowing for easy comparison and analysis. That was really good. It actually got the color. It also got the text correctly, which is really impressive. So that's going to be it for this video, and make sure to like, subscribe, and share. If you do like to see more content like this, do not forget to hit that bell icon. Make sure you do subscribe. It really helps a lot, especially as we are on our way to our first 1,000 subscribers, and that's our first milestone basically that we're actually trying to get to. So it will be really, really helpful if you do help us achieve that by subscribing. And thank you for watching, and have a nice one.